Today, we are going to discuss integrating partial fractions. In number 6, we have the integral of x to the fourth power minus 5x cubed plus 6x squared minus 18 divided by x cubed minus 3x squared of dx. Okay, since the degree of polynomial in the numerator is greater than compared to the denominator, so first we are going to divide the integrand. So you can write here first as x raised to 4 minus 5x cubed plus 6x squared minus 18. So I'm going to divide using the long division. So divided by x cubed minus 3x squared. So we have now the quotient in the first term, we have just x. Then multiply, we have x the power of 4 minus 3x cubed. And then subtract. And then change the sign of the subtrahend. So therefore, this is 0. This becomes positive. So therefore, the difference is negative 2x cubed. And then bring down the next term. We have positive 6x squared. So now let's divide it again. So let's concentrate on the first term, the negative 2x cubed divided by x cubed. So we just have negative 2 and then multiply. Negative 2 times x cubed is negative 2x cubed. Negative 2 times negative 3x squared. Here we have positive 6x squared. And then subtract. So change the sign of the subtrahend. This must be now positive and this must be now negative. So this one is 0. This is also 0. So bring down now the next term. We have negative 18. So we have now the quotient of x minus 2 plus negative 18 over x cubed minus 3x squared. So in this case, we can now write the integrand as the integral of x minus 2 plus the negative 18 of over x cubed minus 3x squared of dx. Okay, so or I can now extract the negative sign here. So I can change now our integrand as we have the integral of x minus 2. So positive times negative. So we can now have negative. So minus 18 over x cubed minus 3x squared of dx. So after that, we are now going to work with the second term, which is now 18 over x cubed minus 3x squared. So first, we're going to factor out the denominator. So we can write now as 18 over the common factor is x squared. So times x minus 3. So we are going to write now the equivalent partial fractions of 18 over x squared times x minus 3. So it can be written as a over x plus b over x squared plus c over x minus 3. So from here, we're now going to multiply the entire equation by its LCM. So I will rewrite it first as 18 over x squared times x minus 3 is equal to a over x plus b over x squared plus c over x minus 3. And I will multiply the entire equation by its LCM, which is now the denominator, which is now x squared times x minus 3. So the LCM divided by this denominator, the quotient is 1 times the numerator, so we have now 18. And on the right side, so the same procedure, so LCM divided by x, so the quotient is x times x minus 3 times the numerator, so we can write now ax times x minus 3 plus the second term, the LCM divided by x squared. So the quotient is x minus 3 times b. So we can have b times x minus 3 plus the third term, the LCM divided by x minus 3. So cancel the x minus 3. So we have now x squared is the quotient times the numerator. So we have now cx squared. Okay, since the factors now is a combination of a linear factor and a quadratic form, so we are going to use the long process to solve for the value of a, b, and c. So we have here 18 is equal to, so we have a times x squared minus 3x plus b times x minus 3 plus cx squared. So what I did, I just multiply the first term with the x times x minus 3. So now I'm going to start with the x squared. So we have x squared. So the coefficient of x squared now on the first term, we have a. Then on the second term, we don't have the coefficient for x squared. But on the third term, we have the coefficient of x squared, which is now c. So plus c is equal to, we are going to find the coefficient of x squared on the left side. But on the left side, we only have a constant, so we don't have the coefficient of x squared. So therefore, I will write here 0. Now for x, the first power or just x, so in the first term, we have a times negative 3x. So the coefficient of x now is negative 3a. And on the second term, we have b times x. So the coefficient of x is positive b. And on the last term, we don't have the coefficient of x, so we will just write up to b. And this will be equated to 0 because there is no coefficient of x in the left side. So for constant or x to the power of 0, so we just write on the first term, we don't have a constant term, plus on the second term, we have b times negative 3. So the coefficient now, the value of the constant there is negative 3b. Plus, on the next term, we don't have a constant, so we just write here, negative 3b is equal to 18 because there is a constant value of 18 on the left side. So therefore, our first equation is a plus c is equal to 0. And second equation now will be negative 3a plus b is equal to 0. And the third equation now we have negative 3b is equal to 18. So I will start now on the third equation to solve for b. So we have to divide negative 3b equals 18. So dividing both sides by negative 3. So we have now b is equal to negative 6. So after solving for b is equal to negative 6, I would choose now equation number 2 because there is an equation such as negative 3a plus b is equal to 0. So we know now the value of b, so we can solve for a. So using now equation number 2, from equation number 2, I have negative 3a plus b is equal to 0. And then substitute the value of b. We have negative 3a plus the value of b now is negative 6 is equal to 0. So transpose. So I have negative 3a is equal to positive 6. Okay, dividing both sides by negative 3. So therefore a is equal to negative 2. Now we can solve for the third variable, which is the letter C. So I'm going to use now equation number. So using equation number, so I have A plus C is equal to 0. We know the value of A, which is now negative 2. So negative 2 plus C is equal to 0. Transpose negative 2 on the right side. Therefore, C now is equal to positive 2. So we now know the value of A, B, and C. Now we're going to substitute to our equation to its equivalent partial fraction from the given. So we can write now the equivalent partial fractions. We have the integral of x minus 2 of dx minus the integral of 18 over x cubed minus 3x squared of dx. So we solved earlier the equivalent partial fractions of our second term. So from the second term, we have the negative of the integral of 18 over x cubed minus 3x squared. So let us solve that one first. So I will just write here on the left side, we have the integral of 18 over x cubed minus 3x squared of dx. So we solved earlier the equivalent partial fraction of that. So we can write now as a over x plus b over x squared plus c over x minus 3 of dx. So we have solved earlier the value of a, b, and c. So we're just going to substitute the value of the variables. So we have now the value of a, negative 2. So I have negative 2 over x plus the value of b is negative 6 over x squared plus the value of c is 2. So 2 over x minus 3 of dx. So separating the integrals, so we can write as negative 2 the integral of dx over x minus 6 the integral of dx over x squared plus 2 times the integral of dx over x minus 3. So on the first term, we have just du over u. When u is equal to x, then du equals to dx. So I can write here negative 2 ln of x minus, in this case, that can be written now as minus 6, the integral of x to the power of negative 2 of dx, plus, on the third term, when u equals x minus 3, so du is just equal to dx. So I can write now 2 times the ln of x minus 3 plus a constant. Okay, so let us now simplify the second term. So I'll just rewrite the other terms, such as the first and the third term. So I have negative 2 ln of the absolute value of x minus 6 times negative 1 over negative 1 plus 2 ln of the absolute value of x minus 3 plus a constant. So simplifying further on the second term, so I have negative 6 divided by negative 1. So that will become now a positive 1. And take the negative law of exponent, or for x to the power of negative 1. So I can write now as negative 2 ln of the absolute value of x plus 6 over x plus 2 ln of the absolute value of x minus 3 plus a constant. So this entire thing will be replaced on our second term. So I can write now the integral of x minus 2 of dx minus the negative 2 ln of x plus 6 over x plus 2 ln of x minus 3, then close, plus a constant. Now, what I need is just the integration of the first term. So I can write now as x squared over 2 minus 2x, and then multiply now by using the distributive property of the negative sign. So let's multiply now the negative to the inside the bracket. So I have now positive 2 ln of the absolute value of x minus 6 over x minus 2 ln of the absolute value of x minus 3, and then plus a constant. Okay, for number 7, we have the integral of x squared over x squared plus 1 of dx. So in this given, we are still going to divide because it says that if the power of the numerator is greater than or equal to the power of the denominator, then we have to divide it first. So showing how to divide, so we have x squared is divided by x squared plus 1. So x squared divided by x squared is 1 times x squared plus 1, then subtract. So therefore, change the sign of the subtrahend. So this is now 0 and this is now negative 1. So the quotient for that now will give us 1 minus 1 over x squared plus 1. So this is now the equivalent of our integrand. So I can write now as the integral of 1 minus 1 over x squared plus 1 of dx. So expanding this one, I can write now 1 times dx. So we have the integral of dx minus the integral of dx over x squared plus 1. So the integral of dx is just x minus this one now is similar to, we have a pattern for that. We have the u squared plus a squared. So we have now the answer for that as 1 over a arc tangent of u over a plus a constant. So our u there is x squared and a squared is equal to 1. Then take the value of u and a. So we can now have x minus 1 over 1 arc tangent of u is x over 1 plus a constant. This is a constant. And so we can now write as x minus arc tangent of x plus a constant. So simple as that. Okay, for number 8, we have the integral of 1 over x squared plus 4x plus 5. So to solve for this, we are going to check our denominator if the value of the discriminant is less than 0 or greater than 0 or equal. So in that case, we have, so I will let delta is equal to our discriminant. We have b squared minus 4ac. So our b is 4. So we have 4 squared minus 4 times the value of a is the coefficient of x squared, which is now 1 times the value of a constant is 5. So we have 4 squared is 16 minus 4 times 1 times 5 is 20. And this is now, the delta now is equal to negative 4, which is less than 0. So if that's the case, okay, we are now using this condition. So if delta is equal to b squared minus 4ac less than 0, then we can use the following method to evaluate the integral. So I will try to use first this formula, although there's another solution for that by using the completing the square. So I will try to show the two methods in solving this one. So following that rule, so I can write first now the x squared plus 4x, so plus 5. So I factor that one. So we have now x squared plus 4x plus, find the number to be added. So we have 4 divided by 2 is 2, then 2 squared equals 4. So plus the last term we have 5, then minus the number that we added, which is now 4. Let's try to factor now inside the quantity. So that is now x plus 2, the square, plus 5 minus 4 will be combined. So we have now positive 1. So in that case, I can rewrite now our given as 1 over x plus 2 squared plus 1 of dx. So using the formula that I have shown earlier on top of our discussion, so our m, okay, we have m is equal to 1 and n is equal to 2 and r is equal to 1. So the formula says that we are going to use this as 1 over rm of r tangent of mx plus n over r plus a constant. Or you can use the negative 1 over rm of r cotangent. Instead, r cotangent of mx plus n over r plus a constant instead of this. So but I prefer to use the positive side, so we can write now the arc tangent. By substituting the value of rm and n, so we can have now 1 over r is 1, your m is also 1, so we have now arc tangent of mx plus n. We have now here x plus 2, we have x plus 2 over r, where r is also 1, so plus a constant. So finally, the answer now will give us 1 over that, it's just 1 over 1, it's just 1. So we have now arctangent of x plus 2 plus a constant. Now, on the second method of solving for that, the other method for solving for that is you are just going to use the completing the square. So we know that x squared plus 4x plus 5 is not a perfect square trinomial. So we will make this one as perfect square trinomial. So by using the completing the square. So I can write now as x squared plus 4x plus the number to be added. And then this will be grouped together plus the last term, which is now 5. So we know that to solve for the completing the square, we're going to find the value of b, which is now 4, and then divided by 2. Whatever the quotient will be raised to the second power. So that is now equivalent to 4 is the number to be added. So I will write here 4, but whatever we added must also be subtracted to that the same number in order for that to go back to the original given. So now we can have, we are going to factor now inside the parentheses. So it will give us the square of binomial. So therefore this is now x plus 2, the square. And then 5 minus 4 is just equal to 1. So therefore, we can now rewrite the given as 1 over x plus 2 the square plus 1 of dx. So from here, we are going to identify our u squared, which is now is equal to x plus 2, the quantity squared, and our a squared is just equal to 1. So solving for u, we have x plus 2, and solving for a is just equal to 1. We know that this integral now is similar to du over u squared plus a squared. And as we know that if that is now the integrand, then the answer for that will be equal to 1 over a arctangent of u over a plus a constant. Now, since the given now is similar to this, so I can write now the answer as 1 over a, but 1 over 1 is just equal to 1. So I can write now as arctangent of u, which is now x plus 2 divided by 1 is just the same as x plus 2, so plus a constant. So I guess this method is quite simpler without memorizing the formulas to be used as compared to this formula. Okay, so it's very easy now to use, solve for that. Just use only the completing the square. Last number now is number 9. So we have the integral of 3 ln cube of x plus ln squared of x plus 4 ln of x plus 4 all over x times the quantity of 3 ln squared of x plus 7 ln x minus 6 of dx. So the given is quite complicated, but if you are going to let u as ln of x, then it looks like simpler. So let's try to rewrite first the given. So I will write u equals ln of x. So u here is equal to ln of x, and the derivative of that is just equal to 1 over x of dx, or just dx over x. So rewriting the given now, so I can write as we have 3 u cubed plus u squared plus 4u plus 4 all over, we have the dx, and over x is equivalent to our du. So the other terms now, we have 3u squared. So I have 3u squared plus 7u minus 6. So after letting u is equal to x, to ln of x, then we can now divide this one because the power of the numerator is greater than compared to the power of the denominator. So dividing that one, so I can write here now. So I will just write 3u cubed plus u squared plus 4u plus 4 divided by 3u squared plus 7u minus 6. So focus first on the first term. We have 3u cubed divided by 3u squared. So the answer is just equal to u. Okay, and then multiply u times 3u squared is 3u cubed. Then u times 7u is 7u squared. And u times negative 6, we have negative 6u. And then subtract and change the sign of the subtrahend. So therefore, 3u cubed minus 3u cubed is 0. And this can be now negative sign. So we can have negative 6u squared. And this is now plus 10u. And then bring down the last term, which is now positive 4. Now concentrate first on the first term, negative 6u squared divided by 3u squared. So the quotient is negative 2. Then multiply negative 2 times 3u squared. We have the negative 6u squared. And negative 2 times positive 7 is negative 14u. Negative 2 times negative 6, we have positive 12. Okay, and then we are going to subtract. So to subtract that, the new sign now will become positive, positive, and this will be negative. So we can now write this one is additive inverse, that is 0. So 10 and positive 14. So we can now have positive 24u. And this is now positive 4 and the negative 12. So we have the negative of 8. So the quotient now will give us u minus 2 plus 24u minus 8. By the way, we stop here dividing because the power here is less than compared to the power of 2. So therefore, we have now u minus 2 plus 24u minus 8 all over 3u squared plus 7u minus 6. So I will just continue this one here. The equivalent for our integrand will be equal to the integral of u minus 2 plus 24u minus 8 over 3u squared plus 7u minus 6 of du. So solving now for our second term, we can write now 24u minus 8 all over 3u squared plus 7u minus 6. So I'll factor out also, I will simplify the numerator first. I have 8 times 3u minus 1 all over 3u squared plus 7u minus 6. Okay, since I simplified the numerator, so I can rewrite also here the numerator. We have the integral now of u minus 2 of du plus the common factor is 8 times the integral now of 3u minus 1 over 3u squared plus 7u minus 6 of du. So I'm going to solve now here for the new term. We have 3u minus 1 over 3u squared plus 7u minus 6. So I'm going to find or write the equivalent partial fraction of this. So I'm going to factor the denominator. So I can write now 3u minus 1, and the factor now of the denominator, we have 3u minus 2 times u plus 3. So I'm going now to write the equivalent partial fraction. So we have here 3u minus 1 over 3u minus 2 times u plus 3. So the equivalent partial fraction of this will be equal to a over 3u minus 2 plus b over u plus 3. Now, since the denominators are all linear, so we can equate that one to 0 to solve for the value of u. So I will start first with 3u minus 2 is equal to 0. Therefore, 3u is equal to 2, and u now equals 2 thirds. Now, on the other side, we have u plus 3 is equal to 0, and u now is equal to negative 3. Next is we are going to multiply by LCM. So multiplying now the entire equation by LCM. So 3u minus 1 over 3u minus 2 times u plus 3 is equal to a over 3u minus 2 plus b over u plus 3. So to eliminate the denominator on the left side, so I multiply by LCM, which is now 3u minus 2 times u plus 3. So this one, the LCM divided by this is equal to 1 times the numerator is 3u minus 1 is equal to LCM divided by 3u minus 2. So the quotient is u plus 3 times a. So I can write now a times u plus 3 plus b times this one divided by u plus 3. The answer is 3. The quotient is 3u minus 2. So times b. So we have now 3u minus 2. Okay, so since I already solved for the value of u, I was just so in hurry to solve for that. So now I'm going to substitute the value of u in this equation. So if u is equal to 2 thirds, now we can write 3 times 2 thirds minus 1 is equal to a times 2 thirds plus 3. So if I'm going to substitute 2 thirds here, this term becomes 0. So I will not write anymore b. So simplifying this one, we have 3 times 2 thirds is 2 minus 1 is 1 and is equal to, the LCD is 3. So that is now, okay, so that one now will give us 11 over 3 of a. So therefore, our a now is just equal to 3 over 11. Now, if u is equal to negative 3, so I can write now as 3 times negative 3 minus 1 is equal to, if I'm going to substitute u as negative 3 here, so negative 3 plus 3 is 0 times a is 0, so I will not write anymore a. So therefore, we have b, we have 3 times negative 3 minus 2. So simplifying that one, this 3 times negative 3 is negative 9. Minus 1, so we have negative 10 is equal to, we have 3 times negative 3, we have negative 9 minus 2, so will give us negative 11. So negative 11 of b. So therefore, b now is equal to, divide both sides by negative 11. So the value of b now become 10 over 11. Since we know already the value of a and b, so I can solve now the equivalent partial fraction of our second term yet. So our second term, we have the coefficient of 8 here, and then 3u minus 1 all over 3u minus 2 times u plus 3 is equal to the integral of a over 3u minus 2 plus b over u plus 3 of du. Substituting now the value of a, so I forgot to write 8, so I can write now 8 times the integral of a now is equal to 3 over 11, 3 over 11 of 3u minus 2. We have the integral plus, this will become du, plus 10 over 11 of u plus 3 of du. Since the denominators here of the value of a and b is common, so I will factor out the common denominator of 11. So I can write now here as 8 over 11 times the integral of 3 du over 3u minus 2 plus we have 10 du over u plus 3. So by integrating, I will let first here as w is equal to 3u minus 2 and dw now is the derivative of 3u minus 2 is just equal to 3 du. But 3 du now is visible in our numerator and that's equivalent to dw. So we can write in here as dw over w. So on the second term, if I let v is as u plus 3, then dv now is just equal to du. So by rewriting now the given in terms of w, dw, as well as v and dv, so we can write now as 8 over 11 times the integral of 3 du, which is now dw over 3u minus 2 is w. That's the integral of that. Plus, I can, since our dv is just du, so I will write here 10, the integral of dv over v. So therefore, the integration of the second term, we can write now as 8 over 11 ln of w plus 10 ln of v plus a constant. But we are not yet done because that's only the integration of the second term. So rewriting now again from the first term. So we can write here as the integral of u minus 2 of du plus 8 times the integral of 3u minus 1 over the factor of that is 3u minus 2 times u plus 3. So on this second part, we solved it earlier. I will just copy the answer for this from here. We have 8 over 11. I guess there's a lacking here. We have the quantity. There must be a quantity of 8 over 11 times the quantity of 11 of ln of w plus 10 ln of the absolute value of v plus a constant. So I will just write here the quantity. So, okay. So now I'm going to write here. We have the integral of u minus 2. We have u squared over 2 minus 2u plus the integration of the second part, which is 8 over 11 times, so the integration of that, we have ln of w, the absolute value of w, plus we have 10 ln of the absolute value of v plus a constant. Now, I'm going to replace the value of u and w. So, I'll start first with the w. So, we have here u squared over 2 minus 2u plus 8 over 11 times ln of w. Our w here is 3u minus 2 plus 10 of ln of the absolute value of v, which is now the u plus 3, and then close plus a constant. But our u is equal to ln of x. So rewriting now the meaning of u, so I can write now as ln squared of x over 2 minus 2 ln of x plus 8 over 11 times ln of 3 ln x minus 2 plus 10 of ln of, the meaning of u is ln of x plus 3 close plus a constant. And that is now the final answer for this problem.